You are welcome to Selective class. We are going to have a very short, about 20-minute demonstrative lesson on teaching of Charles law. If you are called to present a lesson for demonstration, you are applying to teach in a school. You say demonstrate a science, a lesson in physics, chemistry for a short period. This is an ideal situation. You can use this for a guide. So this is a 20-minute demonstration to teach a Charles law. Something very brief I will present to teach everyone. So let's go. This demonstration is about Charles law. Let's go. The first thing we are going to use, you show them preamble. What is the lesson about? Preamble focusing on Charles law. The target is you explain the importance of gases as used in balloon, hospital, the air we breathe, everyday activity about gases, the air, the engines, the cars, mechanics, the civil, everything. Gas is very important. Now, three notable scientists displayed this. They are Roberts, Bose, Jacob Charles, Joseph Gelusa. They talk about Charles law, but emphasis will be on what? They talk about gases. Emphasis will be on Charles law. Now, we give them objective. Since on Charles law alone, you are going to the relation between volume and temperature as described by Charles law, and you demonstrate activity. If you are asked to do demonstrative lesson to a school to see a school, invite for demonstrative lesson or online lesson, you must demonstrate to see, and you apply, you ask to solve some question on this. Now, what are some essential questions? Essential questions are questions that will guide the teacher and the student in understanding the lesson very, very well. It will give you the insight, give you something thought-provoking, thought-provoking questions about the objective set for yourself. So the first one, what relationship between volume, temperature in gas is described by Charles law? How can practical activity be used to demonstrate Charles law? Be demonstrate Charles law. You said this to the student, and when they get this, I think understand me there. How can Charles law explain to solve problem in observation or data analysis? So we are going to give them some questions to solve after this. So these are essential questions. And in the United States, we look at academic vocabulary. There are a lot of things you look at. You know your students will have different nationals. Obviously, the Spanish dominate. So these are the three key academic vocabulary. There are more things. Can talk of absolute temperature, can talk of compression, can talk of a increase, volume increase, decrease, volume compression, absolute temperature, Kelvin scale, all those things are there. But as a presentation, you just write these three key physical quantities: pressure, this is what it is, and pictorial view, you must show picture of a pressure for students to have the concept, volume, temperature, everything is here for them to understand. Now, in US time, normally United States, America, the lesson plan, they have activation of pro knowledge background, or other kind they say RPK, relevant previous knowledge, relevant previous knowledge. But in the United States, normally they say activation of pro background knowledge or warm-up question. So we tell them, teacher group students and ask them some brainstorming questions. So the idea is on Charles law, so you must target your question very well. Why do car tires sometimes best on very hot days, especially when traveling on a top speed? So the students, you expect them to bring an idea. They will surely say something. Grade 10 students will surely say something. Since they know you are going to tell them, they are going to use three physical quantities: pressure, volume, and temperature. They should think around that circumference. So quickly, they will begin to say something: increase in temperature, increase in volume, increase in pressure. You write those things down on a board and you guide them. I give them insight to the question. So why do basketball or soccer ball deflate during cold weather? They also talk about pressure and volume here. So you ask them, give them some time. That is, they give them some time to discuss it. So the next thing is you give them the answer on a board. So the car deflates due to temperature rises. When temperature rises, there's increase in volume due to pressure, and when the temperature of a hot weather increases too much, since the volume is so fixed, it will burst. So tell the student that there's a relation between volume and temperature. So you are giving the insight of Charles' law, which is volume and temperature. The next explanation, it's about a soccer ball. They should summarize it, tell them that hot weather, since temperature increases pressure, decrease in temperature reduces pressure. So when this happens, reduces in pressure means deflation will happen. The ball will no more be inflated as expected. It will look quite soft. So there's a relation between volume and temperature. So the student can read this to understand it better. So you will discuss it in a brief now. The next thing is you are going to start the lesson. Introduction to Charles' law now. You state the law. We state that at the volume of a fixed mass of gas at constant pressure direct proportional to absolute temperature. Let the channel that V direct proportional to T. Already the insight, you have some insight about the question, so they have an idea what is happening already. So they are talking of volume and temperature. This is the man. Give them small preamble. It's just 20-minute lesson, so you must be very fast for them to understand. Now you give them the mathematical relation Vt, T is equal to D, Vk, the subject, V over T, using two relation, give it V1, T1, V2, T2, and this is the mathematical relation to calculate the pressure and the temperature of a particle. Coming to the graph, this is a graph. Since both V direct proportional to T, it means that V increases as well as T. So the graph will be a straight line graph. We explain to the student that if you match this closely, when V increases, T increases, and the graph is a straight linear graph like this. So you just summarize the lesson to them. Now the next thing is you explain by welcome. You are going to use simulation to explain Charles' law very well. Let's start afresh. This is a system. This is the volume of a system. This is the temperature. As you can see the cursor. This is the pressure. This is the pressure meter. The pressure is having calibrated, and this is the pump that will enter, give you a particle. So we introduce some particles to the system. Introduce particles. So we introduce some particle by virtue of want to see different color. So we introduce different color of particles there so that can be visible very well. We want to raise the particles to 500 each. As you raise the particle, what happens? You can observe that the pressure is increasing. So let me explain here very well. You observe that when particles are introduced into the system, collision is going on. We can see the collision meter. You can see the number of collisions that's happening per second. Per second, this number of collisions. So as the particles collide with one another, particles per unit area, it raises the pressure increases. Good. If you introduce more particles, you can observe that the pressure moves. Good. The collision increases, which means there are more pressure. Now, when you reduce it, you reduce the number of particles, the pressure there reduces. Good. Which means that the more gas you inject to the system, the more collisions, the more pressure. The more the pressure. Shall we explain the Charles law now? Charles law states at constant pressure. So this is, you are going to hold the pressure here at constant pressure. What happened? So before we hold the blade, let's make the pressure the same. Okay. So at constant pressure, what happened? The volume of a gas is directly proportional to its temperature. The volume of this gas, the size, the volume directly proportional to this is the temperature. This is a temperature, and this is increase and decrease. We increase the temperature, we introduce heat. We decrease it, we introduce cool. So shall we increase the temperature and see what happens to the volume of the gas particle as we hold the pressure? So we introduce temperature. Can we see, wow, it's increasing, the volume increases. Let's decrease the temperature and see. As we decrease the temperature, we can see the pressure, the volume decreases. Due to the pressure, the volume decreases. Yes. Can we see what is happening? Pressure is hold. We saw increases. Now, shall we increase the temperature? Once we increase temperature, volume increases directly, which explains Charles' law, which
Good.
is V directly proportional to T. So we increase the temperature once again. As I increase the temperature gradually, the volume is increasing.
Good.
It's increasing. It's increasing. Now, let me reduce it. Let me reduce the temperature and see what happens. Volume
Introduce
reduces.
ice.
Excellent. Very good.
Good.
So this explains Charles'
Well
law,
explained.
which says volume and
Good.
temperature are directly proportional, which means when one goes up, the other goes up. When one goes down, other goes down, which
Thank you.
explain we use it to explain Charles' law. Thank you so much. Thank you for listening.
Yes.
Well explained. This explain the Charles' law very well to the student. This is a brief lesson. You do that, you explain only the Charles' law, no, not Boyle's law, not pressure law or Gay-Lussac law. You do that and you let them ask questions. If after the lesson, then you go to the next. Goes to how this is used in everyday activities. So application, you can let them just discuss one or two. This is not captured in the objective, but practically, since you are doing demonstrative lesson, you should capture this. So air balloon, hot air balloon here, which just like is injected with normal helium gas as the air as the air in the balloon expands. How will it expand? You increase there's a temperature here. The air, you inject more gas, you increase the temperature of a gas. When the gas is injected, you heat the gas, they become more, the pressure buildup become evenly spread and it reduce the density of the gas there and it will move up. Why? You increase the temperature, the volume increases, there's reducing density and balloon move up. This is used in train traveling some years back in the 90s and 80s. So still not used applicable now. So this explains Charles' law. So as temperature inside the balloon increases, volume in the air also increases, making the balloon rise due to decrease in density. You summarize it like this, tell them that V directly proportional to T. So this is one application. I think should be just two. The next one is the car they use. So this one was explained. You did that during the preamble, the activation of previous knowledge that hot air, during temperature, hot air, hot weather, temperature increases, the temperature increases, the pressure in the gas expand, the volume of the tire cannot expand anymore. So it has a limited space to expand. When it reaches elastic limit, what happens? It explodes. So there's a lot of explosion. So some cars are high. You let them explain this to themselves. You ask them questions. Use what is your view? What is your view? It should be the lesson should be interactive. So what is on the board, they read. You ask them what is your mind, and they said it, and it made the lesson, your demonstration lesson, very good. So the next thing we are going to look at, we are going to look at other applications. You ask them the air balloon, the tire, the hot air, and a lot of them are there. Put something small there for them not to ask any difficult question. For them, since they're just demonstrating lesson, you do that. Now, the next thing we are going to look at the experiment now, experimentation. This is a must for demonstrating lesson in a class, especially during demonstration. You want a job. So, yeah, welcome. We are going to use this to explain, to demonstrate Charles' law as an activity approach in a class. Physics is activity oriented, so we say thermal expansion of air in a balloon. This activity 1, the material required are balloon. You can see the cursor moving. Balloon, hot air or cool air. You can use kettle, you can use thermometer. We use this thing. Now the procedure, as well explained here, during temperature increases, what happens? You inflate a balloon. You can see here, balloon is inflated. So you measure the temperature, you can see the cursor V1, you can see very big, you can see very big. You measure the circumference of a balloon. You can record it V1. Now you drop it in a hot water, as you can see. You drop it in a hot water. So if you drop it in a hot water, obviously, from the simulation, you also learn as you drop in hot water, the gas, they will gain kinetic energy, they'll begin to move vibrantly. knocking against each other, and they
That's the
create a
particles of the
pressure
gas.
will build up. When
Particles
pressure build up, they will
relation
increase
which
in
will lead
volume.
to
So you
increase in
can see
pressure.
that as you put it inside this one, so allow this to settle 3 minutes. Then what do you observe? Measure and record the temperature. So obviously, on input inside, it will increase in volume. Use it to explain to the student there's a benefit of activities you are doing in a class, increase in volume. So this explains Charles' law, and during the next activity is you drop it in the ice. So when you increase in volume, you can measure the temperature here, you can measure the circumference to measure, you can see the differences in expansion. This is another explanation. So during temperature decreases, drop the balloon in an ice as a control experiment. Drop the balloon in the ice water. You can see the ice water here. This is the boiling water. You drop it, so during temperature decreases, drop it in an ice water and it reduces the volume. This explains vividly Charles' law, which states at constant pressure, volume of a gas is directly proportional to its temperature. So when temperature
Yes.
reduces, volume reduces. When temperature
Good.
increases, volume increases. This is a
Good.
one perfect example you can demonstrate in a class to explain Charles' law to your students. Now, the next activity is you are going to use a bottle where you cover it with a balloon and you heat it up and you cool it again to see the differences in the expansion and contraction by
Contraction.
virtue of pressure.
Pressure.
So you pour some quantity of water in a plastic bottle, cover it, put the bottle in a water, boiling water, allow it. So let's see how it's happening. So this is a heat.
Give this to the
This is the
students.
object. You
Have the
put the balloon
manual
on top of the mouth. You
as you
put
go through.
it here. There's some water inside. What happens? The water, as the balloon gets, as the bottle gets energy, heat energy,
Kinetic
the
energy.
gases will expand. As it expand,
Good.
will trap in a balloon and to expand. This explains that increase in temperature increases in
Volume.
volume of a gas. It's well
Good.
explained here, as you can see. This one is placed, this bottle is placed in a hot water. As you can see, this one, you can invert the balloon in this way and the value will be the same.
Transparent can be seen.
In a nutshell, you can see the various
Degrees, the
degree
temperature
of temperature
degrees.
here. The balloon is placed in different temperature. Let me zoom it and see what will happen. As I zoom it, you can see what's happening here. As I zoom this, you can see this is 140 Fahrenheit and the
Fahrenheit.
balloon is like this. This is 80 and this is 45. So based on the temperature of the respective, balloon, and it increases to that
Temperature
effect.
of respective
So let's go
gases.
to third activity. Third activity, so you can use balloon, can use this method to explain to the students, or you invent it like this, which is a perfect example explaining Charles' law to grade 10, 11, 12 students. Now, when the students are grade 12 students or 11, 12 students, you can use the third one, can use nitrogen gas. Place inflated a balloon into a container filled with liquid nitrogen. Allow it to remain submerged for about 1 minute. So carefully remove the balloon and let's see how it is done. So in a nutshell, you give the student this to follow the procedure. So this is an explanation. The liquid nitrogen, inflated balloon are put inside. Liquid nitrogen has a characteristic of it is about minus 40 degrees Celsius, which is it freezes object to negative 40 degrees Celsius. So when this happens, the balloon, meaning the reduction in heat, the balloon, inflated balloon, you put it inside, it reduces it to a minimum, become a very small. So all this balloon can enter this liquid nitrogen. When you remove it, it gets inflated. So, but this one is a lab-oriented. Man, look for liquid nitrogen to explain the concept. But during this experiment, you can use simple hands-on activity in a class to explain this concept to the students. So demonstration Charles law, we have this balloon experiment, put it in a cool water, hot water, you see the differences in this one as well. This explains Charles law as students to understand that increases in temperature increases what? The volume of a gas. Thank you so much.
Okay, so after this explanation, they do the activity in a classroom.
You see them to be like sometime maximum 8 to 10 minutes as per demonstration. Then move to the next one, which is you give them a piece of paper to do some work. Give them some work to do. You already print out some exercises for them to do. The increase in temperature increases this. They do that. Also, 5 to 10 questions for them to answer, and you collect it. If you collecting, which means every lesson there must be assessment and formative assessment. So this explains your practical oriented and assessment, assessing student progress in a class. So after this concept, you give them exit ticket. What is exit ticket? Normally use it in the United States. At a what do they take along? What are they going to do after the lesson? This exit ticket normally after the lesson as a brainstorming or reflection of the lesson taught. So hot evidence from the experiment support the idea of gas expand when heated. They will tell you something. You discuss, as a summary, discussion of the lesson. How does the shrinking of balloon in a cold air demonstrate Charles' law? They will say, or surely say, they will surely say something. If you are not saying anything, you give them a clue and start. So when this thing is done within 5 minutes, you interact with them. Lesson is well taught, and you just give them homework. Homework, we've not captured this as part of the objective, but as a demonstrative lesson, you let them know that the next time the relation of mathematical relation of Charles' law will be used during calculation. So as you can see, a gas has a volume 2.5 liters, temperature 300 Kelvin. What is the volume? What is the volume at the temperature? So we are giving two temperatures, temperature 1, temperature 2. 1 is here, 2 is here, and only one volume. So you have to calculate what is the V2. To calculate V2 here, V2. Make it V2 the subject, give you V1 times T2 divided by T1. They'll go and do it in the house. They'll bring us a progressive lesson. Lesson is progressive. So this will keep them on toes, and you summarize your lesson and you say goodbye to them. And at the end, is there any questions and answers? There's no question and answer, then you quickly end your lesson. That is the end of the demonstration lesson. Obviously, within 22 minutes, you are done, and everything is done. You see, they'll clap for you, and your job is assured. Thank you so much.